Okay, so what we're going to be doing today is we're going to be graphing inequalities. So we have to understand, first of all, what it means to graph an inequality when we have a parabola. The first thing we'll always have to do is graph the actual parabola. It's going to be a dotted line if it's not equal to, if it's just less than or greater than. It's going to be a solid line if it is equal to. So for this function, I know that this has to be y is less than the parabola. The way that I know that is because what's shaded, I look at the vertex, and what is shaded is below the vertex. So I am shading the y's that are less than the parabola. Over here, here's my vertex. So we are shading the y's what? That are greater than the parabola or less than the parabola? Greater than. For this one, here's my vertex. Y's, the y's I'm graphing, are they above or below the parabola? Above, so this has to be greater than or equal to, right? And the reason it's that is because it's solid. And what would this one be? Y must be less than or equal to. So now we're supposed to match, and you should be able to do this very quickly. So look for the one that is just y is less than. What's it going to be? Which letter? A. Number 2, what are we going to get? C. Number 3. And number 4. Okay, so that should make sense to you. So now we're going to do a couple on our own. We're going to look at numbers 6 and 7. So to graph number 6, the first thing we have to do is look for our vertex. And our vertex is going to be 0, 0. The way that I know that is because there's no b value. There's also no shifting left or right. So I'm going to make a xy axis. Here's the vertex, 0, 0. To graph this quickly, I can look right here. This is something new I haven't shown you. To quickly get my other 2 points, I just go down 5 and over 1. From here, I can go down 5 and over 1. And I don't even have to substitute in points. Here's the way the parabola is going to look. It's solid because it's equal to it. We want to shade the y's that are below the parabola. So where are the y's below? Up or down? Down, so it would be inside of here. Now here's a cool thing you can do. Most people don't know, but you can do inequalities on your graphing calculator. The new calculators work differently, but I'll show you how to do it on the older ones. If you have a newer one, you can bring it up here and I'll try to figure it out, but I haven't done it yet on the newer ones. So I'm going to put in negative 5x squared. Then I'm going to go all the way over here, and I'm going to push enter and enter again. When I have it like this, it's going to shade greater than. That's the greater than symbol. When I have it like, oops, when I push enter again, that's going to be the less than symbol because it's below. It's shaded below the line in that case. And so now when I hit graph, here's the way it's going to look. It's going to show me how my graph should look. Okay? So, yeah, Charlie? Go to y equals, type in the function, then go all the way over here and just keep hitting enter until you get the triangles. So that's going to always shade above it, and that's always going to shade below it. You just keep hitting enter. Can you guys figure out the newer calculators how to do it? Okay. Let me see one of the newer ones. Will somebody bring me a newer one? Bring me yours, Jimmy. I just want to see the difference in how it looks. Okay, so on yours, oh wow. So you just push this. Did you put in the function yet? Okay, just to kind of test it. And then we have to get out of here. And then we're going to type in negative 5x squared and then graph it. Yeah, so it's the same way. All right? Very good. So now let's graph this next one. So first we're going to find the vertex. What's the vertex going to be, Jake?
-4, -1.
Good. So I put my vertex. Then all I have to do is look at this coefficient, and it's -1. So I can literally go down 1 over 1 to get my next point. And all I need are 2 pretty good points. And again, it's solid. So it's going to look like that. Now we want to shade the y's that are above the curve. So that's going to be this outer part here. It's going to look like that. So what that tells me is any dot or any point that lies in that shaded region, all these points are solutions to the equation. None of these points would be solutions to the equation. Question? All right, let's come down to this one. It says an accident investigators use the formula D equals 0.01875 V squared, where D is the braking distance of a car in feet and V is the speed of the car in miles per hour, to determine how fast a car is going at the time of an accident. For what speed V would a car leave a tire mark on the road of over 1 foot? Well, this is our formula that we use, 0.01875 V squared. We want the tire mark to be over 1 foot. So D represents the tire mark. So I want for this value here to be greater than, now would it be greater than or equal to, or just greater than? Just greater than, because it says over 1 foot. If it said at least 1 foot, I'd have to use greater than or equal to 1 foot. So now we have to solve this. So I'm going to have to do 1 divided by, so I'm going to do 1 divided by 0.01875, get that answer, and then I have to do the square root of that last answer, and I get 7.3. Now really, when I do a square root, I should put plus or minus. But in this case, I don't have to do plus or minus because we could never have a negative speed, right? On your test, you're going to be asked to write your answers in interval notation for inequalities. The way I would write this in interval notation would be from 7.3 comma to infinity. So any velocity from 7.3 up to infinity, hopefully nobody drives that fast, will be solutions to that equation. Questions? All right, let's flip over to the back. Okay, so now we're going to have to graph systems. So to graph systems, that means we have 2 equations that we have to graph. So we're going to just do, let's do number 12. So to graph number 12, I'm going to have to find the vertex. Watch how I find the vertex. You can use negative b over 2a if you want. I prefer to find the vertex this way, though. I'm going to do x squared minus 7x minus 8. I'm going to take half of this, which is 7 halves. I'm going to square it, which is 49 fourths. Since I added 49 fourths, I'm also going to have to subtract 49 fourths. So now it's going to become y has to be greater than x minus 7 halves squared. This would be 32 fourths. 32 and 49, that's 81. So it's going to be minus 81 fourths. So there's where the vertex is going to be. I think that's actually easier than doing negative b over 2a. That's going to be down there pretty far. I'm just kind of making these random places here. So 3 1/2, 1, 2, 3 1/2, and that's down about 20. So I'm going to just count it as 5, 10, 15, 20, a little over that. Right about there is my vertex. This is going to open up, and I don't care how exact these are. It's just kind of a rough estimate. For this one, though, I'm going to do negative b over 2a, because it's pretty easy to do. Negative 6 divided by negative 2 is going to be 3. Plugging that back in, negative 9 plus 18 plus 5, that's 9 plus 5, that's 14. And again, I'm going 5, 10, 15, 14. This is going to open down, though. Oh, no, what did I forget to do? Look at this. Yeah, these should be just dashes. That's why you should use pencil. Dashes there. And then this vertex is at 314. This is going to open down, though, so I need dashes. So now I've got to look. The one that is opening down, I'm supposed to be below. The one that is opening up, I'm supposed to be above. So can you see that right in here would be where they would overlap? Does that make sense to everybody? Okay. All right, solving functions or solving inequalities algebraically. We're going to do two problems. We're going to do this one and this one. So on this one, we actually, instead of looking at greater than to start with, we're actually going to do an equal to. I'm going to divide by 16, and I get x squared equals 100 over 16. I take the square root, and that's going to give me plus or minus 10 over 4. And that reduces down to plus or minus 5/2. But now what I'm trying to do is I know these are the x values that make it equal. But I don't really want it equal. I want the x's that are going to make this side larger than this side. So I have to figure this out. Is it going to be all of these numbers in between negative 2.5 and 2.5? Or is it going to be these numbers out here? I have to check that to see. The only way to do it is to check. So I could check negative 10 if I wanted. In fact, that might be pretty easy to do. If I check negative 10 squared is 100 times 16 is 1600. Is 1600 greater than 100? 1600 is greater than 100. So this is going to work down here. What if I check this interval? If I check 0, is 0 greater than 100? No, so this region doesn't work. Check this region. Let's just check 10 again. I'll just do 10. 10 squared is 100. Is that going to work? Yeah. So now we're going to write this answer in interval notation. So it's going to be negative infinity to negative 5/2 union 5/2 to infinity. Those are all of the x values that are going to make that work. Going to make that true. Okay. We'll do this next one, but I'll tell you that it gets really messy because it's not factorable. Let's change one of these signs. Let's change this to a plus. We're going to make it so it does work nicely. So pretend like it started off with a plus there. Okay, so now what I'm going to get is x squared equals 15x plus 34. So x squared minus 15x minus 34 equals 0. So now we factor. Are there numbers that multiply to be 34 and subtract to be 15? 17 and 2. So I have a 17 and a 2, a minus and a plus. So then what are the solutions going to be? Everyone? 17 and negative 2. We're not doing this one, so we can use this space. So we know negative 2 and 17, those are the two numbers that make it equal 0. So I know these two are solutions. because they make it equal 0. But now the question is it these parts that work, or is it the inside part that works? What would be an easy number to check? 0. So I'm going to go back to my original. Is 0 less than or equal to 0 plus 34? Is that a true statement? Yeah. So in between here works. So to write those solutions then, it's going to be in between -2 and 7. Those are going to be the solutions that work. Questions there? All right, we're going to do one last one, the word problem. It says the profit for a hot dog company is given by this equation, where X is the number of hot dogs produced and Y is the profit in dollars. How many hot dogs must be produced so that the company will generate a profit of at least 150,000? Well, here's our profit function. -0.02x squared plus 140x minus 2,500. This is our profit. Do we want the profit to be less than or greater than 150,000? If it says it has to be at least. Yes, of at least? If I say I want you to be at least 16 years old? Right. So this equation is going to have to be greater than 150,000. Okay. Yeah. Yes, thank you. Because it says at least, so that means it can be equal to. It's just like you have to be at least 16 to get your driver's license. You can be 16. All right, now, this problem has some crazy numbers in it. I'm not going to try to do this with the quadratic formula or anything. Here's what I'm going to do. I'm going to go to the calculator. I'm going to put the parabola into y1. So -0.02 x squared plus 140x minus 2,500. Into y2, I'm going to put in 150,000. Now think about this, guys. If I just do a Zoom 6, well, I'll just show you. If I do a Zoom 6, I'm not going to see anything. I'm not even going to see the parabola. So I've got to sit here and adjust this window. I know that the X maxes are going to have to be more than 10. They're not going to sell 10 hot dogs and make much of a profit. Maybe I'll make this 100. Maybe 1,000. I'll do 1,000. Now, what's the profit we want to have at least? 150,000, right? So I'm going to have to make this Y max bigger than 150,000. Let's try 200,000. And now we'll hit graph and see if it works. Uh-oh. What do I have to do?